Hi folks, welcome to this video on finding the constant of integration in certain cases with indefinite integrals. So if we have extra information about the curve, we may be able to find the value of c. So I'm going to give you a case here where the derivative of some function is 2x minus 3. Well, that means the function itself will just be the indefinite integral of the derivative. Okay, that's kind of how integration and differentiation are connected. And we'll have more on that when we get to the fundamental theorem of calculus. So let's see. If I want f of x, I need the indefinite integral of 2x minus 3. And that's one I think I can just do by inspection. What differentiates to give me 2x minus 3? X squared minus 3x plus c. So at this point, it looks like we don't know c, except we know that the point 2, 3 is on f. So when you substitute 2 for x, you should get 3 for y. Well, that could get us down to fewer letters here. So 3 is equal to 2 squared minus 3 times 2 plus c. Or 3 is equal to 4 minus 6 plus c. Or 3 is equal to negative 2 plus c. Oh my gosh, c is 5. So the original function is x squared minus 3x plus 5. That is the unique function that has this derivative and passes through this point. Having that extra piece of information let us know c. If we didn't have it, c would remain unknown for us. That can also crop up in kinematics. So we know that s of t is position, s prime is velocity. So differentiation sort of sends us down here. But if you wanted to move up the scale, well, you'd have to integrate. So if the derivative of position is velocity, then the integral of velocity is time, or is position rather. I'm thinking with respect to time. The integral of velocity is position. So I've got v of t is sine t. So I want to find s of t. I'll have to move up the chain here. Okay, and I'm using the letter t here. So position function is going to be the integral of sine t dt. And the antiderivative of sine is going to be negative cosine. Okay, we could draw that little wheel of trig, and that would help us out. But I have to have my plus c. I don't exactly know where this particle sort of started, and that has something to do with c. Oh, but it looks like I do have some extra information. I actually do know its position, or its initial position, because that's when time is 0. Initial position is 5. I can sub that into this function. 5 is equal to the negative cosine of 0, that's my t value, plus c. Now careful here. The cosine of 0 is 1. So c is 6. And that lets us know that the position function is negative cos t plus 6. Okay, if you put 0 in there, you'll get 5 for position. If you differentiate it, you'll get sine t. So it's really the same as the first question that we did in this video, just more in context with velocity and position. One last tricksy one. So here we know f double prime. We can find f prime by integrating f double prime. So f prime bumps us up a level, essentially. It's going to be the indefinite integral of negative 4. So f prime is going to be negative 4x plus c. And we know that f of x has a max at 2, 5. So, I mean, once we get up to the f of x function, we'll be able to figure out what the constant of integration is, maybe. But we'll also have another constant of integration show up. And here's the sneaky bit. If they tell you it's a max, what are they telling you? Especially since this is going to be a polynomial. The slope at x equals 2 is 0. That's what happens at a smooth max. In other words, f prime at 2, at that x value where there's the max, is 0. And that can let us find c right now. So 0 is going to equal negative 4 times 2 plus c. In other words, c is 8, and f prime of x is negative 4x plus 8. Great. Now we can bump it up another level. F of x is going to be the indefinite integral of f prime. That's what sends us up. Or the indefinite integral of negative 4x plus 8 dx. And you can find that indefinite integral either by thinking about just what differentiates to negative 4x or by using rules. I think it's straight ahead enough that we might just want to go with inspection here. I'm going to use a different letter here. Maybe I'll use d for my constant of integration that comes up this time. But here we know f of 2 is 5. So if I put 2 in for x, I'm going to get 5 for y. And there should be a squared there. And so that's 5 equals negative 8 plus 16 plus d. Or 5 equals 8 plus d. Or d equals negative 3. All that work to find, in this case, 2 constants of integration, and be able to give us a final answer of negative 2x squared plus 8x minus 3. That is the unique function that has a second derivative of negative 4 and has a max at 2, 5. There's some practice that you can do on page 443, numbers 1 to 5. I hope this has been helpful. Good luck with the material, folks, and take care. Ooh, exciting. We have bonus content here. So we're going to deal with sketching an antiderivative. I should say sketching an antiderivative. And that can be kind of tricky because what it means is that you take the original function, and this green function is telling you about slope. And what you need to do is produce a graph that has that kind of slope. So let's catalog these sort of regions here. All throughout this part, up until about x is equal to 3, we have positive slopes. So the antiderivative is rising. And all over these parts, because f is going to tell, let's write this down. F tells us slope on the antiderivative. Here we've got negative slope on the antiderivative. So f is decreasing. Now some other things to notice here. Right here is the lowest negative slope. So that means it's where it's steepest in that little section. And here is the highest positive slope. So again, that's where it's steepest. So I'm making all these rough notes to myself that are just barely legible in my chicken scrawl. And now I'm going to try and set this up. Okay, here we go. Now it does tell us that the big antiderivative at 0 is negative 2. So that's just where we start. And I start with a positive slope, and it goes to its steepest positive slope around x equals 1. Now I actually have no idea how high or low it goes. I'm just trying to get the contour to say exactly how high or low it gets. I don't know. And now it continues to have a positive slope, but it has a smaller and smaller positive slope until we get to just after 3, which is where it has a slope of 0. And then it starts having a negative slope. And it's going to have its lowest negative slope at about, I'm going to call that about 4.5, 4.6. And it continues to have a negative slope, but that slope gets smaller and smaller. The slope is getting closer and closer to 0. In other words, we'll probably have a horizontal asymptote. And once again, I have no idea how high or how low it went, but there's a basic look at the antiderivative. I think it's a lot trickier to graph an antiderivative than to graph a derivative from the original function. But just think about f of x telling us the slope on big F, and then trying to, in little chunks, get that sort of information out there. Where is it steepest? Where is it slope of 0? Where is it going to be of not steep at all slope? Okay, that's it for the bonus content. Take care, folks.